welcome to one of our presentations for the Campus Sustainability Month. Today we have Paige. She's going to be talking about the sustainability of disturbances, and her and I are both interns at the Office of Sustainability. So those applications are coming up soon. If anybody is interested, we'd love to have you guys apply. I'll go to the next slide. Okay, so we've got a few directions for best practices. So for your best viewing experience, I would turn on side-by-side mode, and that should be somewhere up in the top right-ish, I believe. Turn on the subtitles if you need to, or if you want to. I have them on. Mute your mics and you can keep your camera on or off. It doesn't really matter, preferably off, I think. And if you have any questions, just ask them in the chat, and we'll get to them. And then at the end, we'll have a discussion where you'll be free to ask questions. You'll raise your hand, not like physically, but the raise your hand option, or you can just turn on your audio and video and ask it. See, we have another person joining. That's great. So we have Sustainability Champion Awards now. Those are open if you want to nominate somebody. So that's for faculty, staff, and students. We have our internship program, which Paige and I are a part of, opening on the 26th. So next thing, which you guys are probably most interested in, are the prizes. Here we go. So we're going to have a code word, a code word that could be, we're going to have it spoken in the presentation, written in the chat, or whatever. And you're supposed to keep track of them, and you can win prizes. So 2 code words, you can get a water bottle, 3 is a t-shirt, and 5 you get both. So if you meet any of those and you remember your code words, you can email all of them to this email, sustainability@TAMU, by November 9th, whenever you're ready. And so you pick up the prize on College Station campus. You have to be at College Station, and we'll have these up, the recordings up, so you don't have to be watching it live. Oh, not that. Let's get on to Paige. Okay.
All right, cool. So I guess I'll share my screen. Let's see. So I'm going to put this in presentation mode. Can you guys see that? Like the whole thing?
Yes.
Okay, perfect. All right, so first of all, hello, I'm Paige. I am a junior environmental geoscience student here, and I primarily study biogeography, and in that, a lot of my research has to do with ecological disturbances. So that's what this talk is on. And also, if you guys hear like any noises, my dog is in the kennel behind this, so that is what that is. So I guess we can get started. So title is, why do we need ecological disturbances? Ecological disturbances. What do you guys usually think of when I say that word? We're all here for Sustainability Month. You guys probably are pretty deep environmentalists, care about the environment. So what do you guys think? Does anybody have any ideas of what an ecological disturbance is? That's fine. That's cool. Again, we all probably believe in the environment. So a lot of us might first think of something like deforestation or pollution or these anthropogenic things that people bring on the environment that cause issues in the ecosystem and they cause changes. And those are both disturbances. They definitely count, but disturbance is a lot more. It also can be forest fires, human caused or natural. It can be diseases. It could be insect outbreaks, hurricanes, volcanic eruption, mass freezing events, and flooding. All of these things also count as ecological disturbances. And all of these things are important too. So the ecological disturbance is defined as an event or a force, non-biological or biological in origin, that brings about mortality to organisms and changes their spatial patterning in the ecosystems that they inhabit. So it sounds kind of like a mood killer, right? It sounds like, oh no, we're bringing about the mortality of organisms, we're changing their environment. That doesn't sound like a good thing, and it definitely doesn't sound sustainable. And when most people hear about these natural or anthropogenic disturbances, they do typically think about these unsustainable things. Things like they're very destructive. You might have loss of property or even life endangerment. They're unpredictable, they seem really wild, and they often come with a great economic loss. And all of those things are really true and valid. We've seen recently some of these wildfires that are happening across the country, or wildfires in Australia, that are very destructive to ecosystems and to human life and property. Or this year is the second most active year ever in the hurricane season. And we're seeing a lot of these floods in the Gulf that are causing a lot of issues, again, for the ecosystem and also for human life. But that's not the only effect that ecological disturbances have. They're also necessary. Ecosystems really rely on them. They can even mitigate risk if they're managed correctly. Again, if they're managed, they enhance biodiversity, and disturbances like fire and floods and insect outbreaks and disease are all really necessary for ecological management, and they're used by ecologists to manage the environment. So one of the things that we really need to understand while we're talking about disturbance ecology is something called the disturbance regime. And the disturbance regime is defined as a historic pattern, the frequency and extent of a natural process, such as fire, insects, wind, and mass movement that affect the ecosystems and landscapes in a particular way. So an example of a disturbance regime would be a place that has a small ground fire every 3 years, typically. And then maybe they also have a mass freezing event every 50 years, and then they have a major ground fire every 200 years. So something like that, where it repeats in the ecosystem over and over again, and you can predict the outcome and predict the amount of times that a disturbance would happen, that would be that ecosystem's disturbance regime. And every ecosystem on Earth has a disturbance regime that it'll experience, and these can be extremely diverse. It can be something like I just said, or it can be absolutely completely different. So every ecosystem has those, and every ecosystem is adapted to having those. So this concept, the disturbance regime, is going to come up a few more times, and I just think that it's an important vocabulary word to know when we talk about disturbance ecology. So I wanted to get into one of the most famous ways that humans have altered disturbance regimes. Pretty much everybody has probably heard of Smokey Bear. It's the longest government-run PR campaign in history. And the reason that it's so famous and where it came about and where it came from was in the 1800s. One of the reasons that the colonizers here were so successful at building like America into a colony was because there was so much pristine resource there, especially timber. America used to be full of forests, and that was definitely exploited by the colonizers that came here. And so pretty much like a huge amount of the Northeast by the Atlantic coast was all clear cut for both building materials and the economy. So all of the healthy trees were cut down, and that left a lot of stuff left on the ground, a lot of debris from cutting down trees, and it left only the more weak trees standing. So after all this happened, early conservationists were really worried that we were going to just run out of this resource that had created the country, that basically the entire country was founded on. We had cut down a lot of the trees, we were moving further west, and the resource was going to be completely gone. So that was why the US Forest Service was created in 1905. And with it, they were really worried about forest fires taking place. And again, we'll get to why they're worried about that in a little bit, but they're really worried about these forest fires. And a reason the officials thought, like, why would we even start making all these national forests if they're just going to burn down anyway? So active fire suppression was a really big concept in US forestry. And 5 years after the US Forest Service began, there was huge fires They were called the big blowups, and they were where 3 million acres in Montana, Idaho, and Washington just completely burned down. And we'll get to why they burned down in a little bit, but those fires really like freaked out the Forest Service. And so their active fire suppression went really hard. And then in 1944, they created Smokey Bear to be like the face of this campaign and to teach the public to avoid burning their fields and avoid catching accidental fires, to really increase the amount of fire suppression that we had. So here I have a couple of figures for you guys to look at. And the first thing that I want to look at is this one over here, which shows the estimated fire frequency regime, which again, this is a disturbance regime of the Appalachian area before there was any like colonizers here. So this was what as close to natural the fire regime would be. And you can see a lot of places, where did my mouse go? Right there. You can see a lot of places, especially down here, that really burned every like 1 to 12 years. So really frequently, these places were all burning. And even here, much of the mountains burned at least every 25 years. So there were really frequent fires all over the map. There was barely any places that didn't burn, like right here. That's it. And so you can also see that in this graph, which shows the relative fire frequency. And here we have, this is all before forestry, before fire suppression happened. And you can see that there was a relatively middle amount of forest fires going on until right here. And this is what I wanted to talk about, was all of the timber, lumber mills that were happening, all of the deforestation that was happening. All of this debris was left over from that deforestation. And eventually when fire did catch, even though it was more rare, it caught really big. And that is really what freaked out everybody about fire and freaking them out about fire suppression, and why here, this is Smokey Bear, why there was not any fire allowed for the longest time after that, was because of these big fires that were really caused by deforestation and poor management strategies. So that's what those are. So what is so bad about fire suppression? Like, we saw that huge spike of fires that was happening. And clearly that was a bad thing. A lot of things were getting burnt down, forests were burning to the ground. These are really huge crown fires too. So they weren't just healthy, taking out the bottom of the forest layer, clearing out debris. They were like burning down the forest. And so that seems like a pretty bad thing. And it might seem intuitive that we should try to suppress these fires and try to keep them from happening because they're so damaging. But like I said, the spikes in the fires in the late 1800s and early 1900s were caused by the timber industry causing fuel loading. And fuel loading, if you look here in this picture, is all of this stuff that's left on the ground after things were deforested. So all those branches that they hacked down were left on the ground to dry out. All of the trees that weren't good enough and they didn't think were worth taking, left them on the ground. All of the small plants that had sprung up because there was so little shade now, all of those things contributed to fuel loading. And when you have fuel loading, that's just a ton of dry material that can catch on fire next time. And those cause some serious fires. So the same effect happens when forests with regular fire regimes, like we just saw the Appalachian Mountains have, go unburned for a long time. The same thing happens where you might see it here in our forests or back at home in your forest near where you live. There's a lot of underbrush that gets built up and a lot of stuff that might not supposed to be there, maybe invasive plants, maybe tall grasses, maybe shrubs, all of these things that are close to the ground, and they just get loaded and loaded and loaded on, and they never get cleared out by fire. So without having controlled burns and without having small ground fires, which is where only the stuff that's close to the ground gets burnt, all of that stuff is just allowed to build up and build up and build up for a long time until a big fire happens. And then that big fire that happens is much larger than any fire that we would have seen before. And so we've seen that happen recently in places like California, where national funding has been cut for the Forest Service. So they aren't able to maintain these controlled burns like they used to. And now when there is an accidental fire, that fire is huge and it takes out a lot of forest land. It's bad for the ecosystem and it's bad for human life as well. So that's one aspect to why it's wrong, or why fire suppression is bad. And the second one is that landscapes that were once mainly fire dependent species, which there's lots of them, but pine and oak are two common ones, like oak forests, oak savannas, or grasslands, all of those will get taken over by species that can now outcompete. Where they used to not be able to withstand the fire, now they have this chance to come and outcompete that, and their ground gets covered and it completely changes the ecosystems. So those landscapes now are on the decline, and then more common landscapes with better competitive plants are on the incline. So it completely shifts that ecosystem. So, okay, now we're at the code word. So this is riparian, which is something we'll talk about in a little bit, but it's the riparian zone is the interface between a river and a stream, or not it's the interface, sorry, that's typed wrong. It's the interface between a river and the land around the river. So all of that wetlandy place that sometimes gets flooded, that's what that is. So if you guys want to write down the code word, there it is. And I guess just to go back really quick before we move on to the next part, all this fire suppression has been on the decline, but it's not fixed. So in 2001, they changed the Smokey Bear's catchphrase to only you can stop forest fires to only you can stop wildfires, insinuating that now forest fires aren't so bad, but we do need to make sure that those are controlled fires. So just kind of changing the public outlook on what fires are like, saying that they are a good thing and they're not always so bad. So the National Forest Service has been encouraging controlled burns since about the 70s. So things are getting better, but they definitely aren't back to where they were before fire suppression began. So yes, there's the code word. If you missed it, again, go ahead, write it down. I don't know if anybody wants to put it in the chat, but all right. So now I just want to move into a few species that are dependent on disturbances, and they're not all dependent on fires. So the first one is, oops, my guy popped up. Okay, the first one is the lodgepole pine, and the lodgepole pine is thought to be the most abundant tree species in the Western United States and the Western Canada. And so it's fire dependent for a lot of reasons. The first one, which I think is very interesting, is that they have ceratinous cones. And ceratinous cones in conifers, in plants that have cones, their seeds are inside of those cones. And ceratinous cones, plants with those, have a little waxy layer that's surrounding the cone and on the seed that won't open unless there's fire. So the fire will melt the wax off, and then the tree is able to propagate, get those seeds out. Fire, so this plant is absolutely dependent on fire to reproduce. And fire also produces good conditions for seed germination. So fire is really good for the soil. It reintroduces nutrients to the soil, and it reintroduces nutrients and it exposes mineral soils. So those things are really good for seed germination, and they're just good for plant life in general. So also the lodgepole pine has a fire dependent stand structure. So where those trees are located is completely chosen by fire. How old the trees are is chosen by fire. And altogether, this pine tree in particular is very, very dependent on having regular fires. So when we suppress those fires, this tree, which is the backbone of a lot of ecosystems in the West, is not able to reproduce like it should be able to. And that ecosystem has a potential to fall apart. So that is one fire dependent species. Let's look at another. This one is the pitcher thistle. So the pitcher thistle is a little guy, it's a little herbaceous plant, and it is endemic to the Great Lakes shoreline dunes. So the word endemic just means that that species is only in one area and cannot be found anywhere else. So it is endemic. There's not very many of them. There's only one place that you can find them. And these species, as well as many other plant species, require natural shoreline disturbances like storms and wind and rain and flooding to create its habitat. And there is documented proof that human altering of the shoreline processes, like stopping some of the way that these natural disturbances work on shorelines, like the creation of dunes, has harmed the population. So this population is on a decline, and it's because we're altering the disturbance regime. And then the third one I have is the the Rio Willow. And this one lives in the Pacific Northwest. It is a little shrubby tree thing that can grow about 10 meters tall at its best. And this is a flood dependent species. So this is where I was talking about riparian. These species and many others live in that riparian zone alongside of a stream where it floods really often. There's a lot of water. They require a lot of water, and that's what they're adapted to, is all of that flooding. So the floods, not only do the plants require water, but the floods also rejuvenate the soil for them, because those floods will bring new sediment in and new nutrients for those plants to use. So it's very healthy for these plants that are within those flood zones and that are adapted to those flood zones. So floodplains and other alteration to riparian zones has been a significant issue, because we really try to use dams and use levees and all of these ways that we change our river systems in order to preserve human habitats. So we'll take away the riparian zone, take away the flooding for some of these ecosystems that really depend on it, because we don't want to be flooded. And so that has caused damage to species like this willow and species that are also dependent on those riparian zones. So those are my three. Oh man, I didn't know I would do this. Those are my three examples of species. So then we look at this, and so on one hand, disturbances are necessary for supporting ecosystems, including the threatened or endemic species that live in them. We really need these disturbances if we want to preserve those ecosystems. And like I said, like I showed you, all of those species that I showed you were all plants. However, plants are the backbone of our ecosystems. And if the plants start going downhill, then we also see the animals in the area going downhill. And it really just creates this ripple effect. So disturbances are really needed to support the ecosystems because they support plant life. And they're also necessary for preventing larger disasters, like we're seeing with the fire regimes being altered. If we refuse to burn, or if we refuse to let something flood for a long time, things can get really dry, and they can cause even larger wildfires and make things an even bigger deal than they ever needed to be. So that's on one side, is that we need disturbances, absolutely, for ecosystems. But on the other side, human activity isn't really compatible with the natural disturbance regime. It's hard for us, considering a lot of the US requires frequent burning. It's hard for us to find a place to live that naturally wouldn't be burnt. So it's difficult to live alongside of these naturally occurring disturbance regimes. And also, human existence creates new disturbances that ecosystems have to face and adapt to. Like I said before, the first thing you might think of when I say disturbance is something like pollution or something like deforestation, those things that we're causing. And honestly, we do need to be able to cause some ecological disturbances in order to survive as a society. So where's the balance there? And that question, where's the balance, is something that a lot of ecosystem management people, a lot of disturbance ecologists are looking at right now and trying to figure out. So I have 3 suggestions off the top of my head. So what we could do just very generally to be able to make a balance between our need for disturbances and our need to also exist healthy as a human society. So my first suggestion, and what I really think is most important, is that now that we have a good understanding of how important these disturbance regimes are and how they're going to happen regardless of what we do, I think we really need to start planning development outside of disturbance prone zones. So when we're talking about expanding a city, or if we're talking about settling into a new city or towns getting larger or whatever that is, we need to be out of places like fire zones, like extreme danger fire zones. You can see that on the map here. Places in the red are extreme fire zones, and we shouldn't be developing there, because in reality, those places need to be burnt, and they are going to burn at some point, whether that's naturally or if humans cause it. And then another thing is within floodplains. So right now we do try to build outside of floodplains, but a big issue is that those floodplains are actually expanding with climate change and sea level rise. So we need to take into account what the current floodplains are, where they're going to in the future, and how we can build away from those. And just give the spaces that are going to be most altered by disturbances the space to naturally have those things occur. But obviously, we can't move every city that's in a place that has a lot of disturbances going on. So if we do have those cities that are right in the middle of a flood zone, like Houston, or if we have cities that are in California that are in the extreme fire areas, then what we need to do is make sure that our buildings and our code and our regulations are all up to date with disturbance resistant technologies and with things that will be able to keep us safe. So here I have a couple of pictures of what those could look like. This one is a plan for wildfire resistant homes, which I don't know that much about. And then here is a plan for flood resistance, which I'm sure if you guys have been to like Galveston, you'll have seen that all of the houses are on stilts. So things like that, just making sure that our buildings and our infrastructure isn't going to be crushed every time that there is a disturbance will really help protect us economically. And then finally, a huge thing that's really, really important is just enforcing ecosystem management strategies that are similar to the natural disturbance regimes. And that's a huge part of what a lot of scientists are looking into now, is saying, what did this look like before colonizers were here, before we seriously altered these regimes? How often was it burned? Was this a wetland? How often did this floodplain flood? What was important to this ecosystem to support it? And how can we replicate that? And so things like controlled burns, wetland restoration projects, and invasive plant removal are all a part of cultivating our own disturbance regime that's as close to what is natural as possible. So those three things, getting out of these disturbance zones, building things to code so that will be safe when there is a disturbance, and then making sure that ecosystem management strategies are put in place so that we can mitigate the damage as much as possible and protect the ecosystem as much as possible. My dog just sneezed. All right. So in conclusion, disturbances are really, really needed for ecosystem sustainability and for human health. And it's important for us to respect the natural disturbance regimes and make sure that we're working with them and not against them. So I think that's all I have for you guys. I can take any questions that people have if you want to, but yeah, cool.
I actually have a question for you.
Yeah, for sure.
So I was wondering, whenever you gave examples of disturbance-dependent species, they were all like plants. I was wondering if there are like animals that are disturbance-dependent.
Yes, I would say so. Most things. Okay, I'll give an example with something I know in streams and waterways. So there are some fish that would. Let me back up with this. So when we put dams in, it causes major problems in like the wetlands ecosystem and also in the river ecosystem because it stops a process called sedimentation. And sedimentation is where the sediment from upstream comes downstream and then deposits along as the stream flows. And when you build a dam, all of that sediment will settle above the dam and isn't allowed to continue on. So there are some species of fish and other wetland animals that will like lay their eggs in the side of these streams and in the loose sediment that builds up in streams. So if they are, and they also, for that, they require disturbance of the sediment coming in and they require flooding. And so in order for that to happen, it would need the sedimentation to take place, but our alteration of that disturbance regime makes it so they aren't able to lay their eggs in as many places. So I guess that would be my biggest example of what it is. But again, I study plants, so most of my examples are plants. But also because plants are the primary trophic level in an environment, when they're not able to be successful, the animals in that environment are also not able to. So that would be what I think.
Awesome. Just a reminder, if you do want to ask a question, just go ahead and unmute yourself and go for it.
Yeah, you guys can also type it in the chat if you want.
Yeah, no pressure. All right.
Okay, well, cool.
If we don't have any more questions, I do have one more thing to show you guys.
Awesome.
Gotta share the screen. Let's get to it. Okay. Y'all can see that. So we have up next on October 26th, which is our next presentation day, we have Dr. John Nielsen Gammon, who is a professor here, and he's also the Texas State climatologist, and that'll be a good one. It's at 11 to 12. After that, we have Caroline Ask from the City of College Station coming, and then later we have a group of our sustainability interns as well. So feel free to come to those. They'll be great. And then just another reminder, the code word is what, Paige?
Riparian.
There we go.
It's in the chat if you want to spell it. I don't know if I'm saying it right. So.
Me either. Okay, so I'll go ahead and end the meeting. I figured it out.
Thank you for coming.